Third graders, welcome back to the next part of our math session. And today's math session is called Think Before You Subtract. Before you get started, I would have either your math journal or notebook ready to copy down some of these equations. In the slide, there is also a page of all these equations and some spots for you if you'd rather try to print this page out and show your work on a worksheet rather than your journal. So either way today is okay with us. So we're going to talk about think before you subtract today. And if you take a look at this first one, it's 62 minus 29. And I want you to not really dive in and try a strategy that you know, and by now you have one that's very successful, hopefully for you. But I want you to think about maybe what could you do to these numbers to make it a little bit more friendly. I know we've been talking about rounding and constant difference. We've also been talking about adding up to get another one. So I want you to think about that and think about what strategy you have that might be the friendliest or easiest way to do it rather than doing the same one over and over. Because remember, we need to have a bubblegum brain, not a brick brain. So pause the video for a minute and just think about what you might do. Okay, go ahead and try solving it either in your math journal or on the paper here that you possibly have printed out. And let's take a look at some possible ways that you might have done it. So here are some ways that you might have done it. Some of you might have tried it using the subtraction algorithm that we explored yesterday by borrowing a 10 from the 10 spot to make this 2 into a 12. 12 minus 9 is 3. 50 minus 20 is 30. Or maybe you're thinking constant difference. 29 is really close to 30, so if I just shift that over by 1 and shift this number by 1, I can see that the difference between this is 33. So is this, because I shifted both numbers. Or maybe you'd want to think about it like this. I can just add plus 1 plus 1. Some of you might be trying it on a number line by starting at 29 and adding up to 62. Although that might be more work than is needed here for this particular problem. Let's look at the next one. Here's 85 minus 27. Pause the video for a moment and think before you try this next one. Okay, give this problem a try in your notebook or your journal or on this piece of paper. All right, so for this one, you might be thinking to yourself, all right, maybe I could try doing it this way, and I could try doing 85, and I could take my 85, and I can't take 7 away from 5, so I'm going to have to cross out my 5, and I'm going to have to make this take a 10 away from this to make this a 15, and then since I borrowed a 10 here, this becomes 7 tens. 15 ones minus 7 ones is 8 ones. 70 minus 20 is 50, so that's my answer. Or maybe I want to add 3 to this to get to 30, and then I want to add 3 to my top number to make it 88. And then if I try to subtract these, that's a little easier. 80 minus 30 is 50. 8 ones minus 0 ones is 8 ones, and I can do that. Now, if I try to do it this way, which many of my students are, and they're trying to get to 30, and then we add our 50 to get to here, and then we get to plus 50, and then we're already at 80, and then we get 5 more, and I get to 85. So notice how many steps I took there. I took 1, 2, 3, and then I had to add them all up to get 3 plus 50 plus 5 is equal to 58. That's a lot of steps. That's 1, 2, 3, 4, like 4 steps. This step right here is only 1 or 2 steps, and this also is 1 or 2 steps. So that's why I'm having you pause the video to think about what you're doing before you add. Can you make it easier on yourself rather than doing a bunch of work and possibly make a mistake? So let's take a look at another one. Okay, here's a 3-digit problem. I'd like you to pause the video, think about what you might do, and then give this one a try using your brain first, thinking, is there an easy way to think about what this problem might be when I subtract these two numbers? Okay, now that you've tried 202 minus 149, here are some ways that you might have thought about that. You might have thought about the actual US algorithm, which is borrowing a 10 from here. So if I borrowed a 10 from here, I can't borrow anymore, so I gotta borrow 100 from here. So now I have 12 here because I borrowed a 10. I had to borrow 10 tens from here, or 9 tens from here. And then I had to borrow, and then I don't have anything left, so I have 100 minus 100 is 53, 90 minus 40 is 50, and 12 ones minus 9 ones is 3. Or maybe you did it finding the difference on a number line. Many students like this. 1 away from 49 is 150. Add a 50 to get to 200. Then add the 2 to get to 202. I add these numbers up here and get 53. Or maybe you want to do constant difference, which is what I would have done. 149 is real close to 150. So I'm going to add 1 to each number to give this a friendlier way to subtract. 203 minus 150, I can do that in my head to get to 53. So that's one way to look at it. Let's take a look at this next one, which is 709 minus 663. Pause the video for a moment. Think about what you would use to help yourself with this one. And give it a try. So pause the video, think about it, and give it a try. Okay, so now that you're back, let's take a look at some possible ways that you might have tried this. So first of all, you might have tried the US algorithm. 9 minus 3 is 6, so we can do that. You can take away 3 from 9, but you can't take away 6 from nothing. So that means you're going to have to go borrowing from 100, and you're going to take 10 tens and put them up here because we're going to borrow 10 tens here. 10 tens minus 6 tens is 4 tens, and 600 minus 600 is nothing. Or maybe we could find the difference on a number line. Start at 663. Add 7 to get to our friendly number, then go a big jump to the next friendly number of 700, which is 30, and then add 9. We add them all up and we end up with 46. Or, you know what, constant difference isn't too bad. If you are pretty good at playing I Have You Need, you might know that we're 37 away from a really close friendly number here to 700. So 37 plus this number is 700. So I'm going to add 37 to this one and get 746, which is 46. So maybe you want to try to determine what way is easiest for you. A few steps here, a few steps here, a couple of steps here, but there could be chances for a mistake with that bigger one of taking these big jumps here. So you have to determine what works best for you. It's kind of like in Writer's Workshop when we're kind of like our own job captain, finding out what strategy is going to give me the right answer and I'm doing not too much work. Okay, so let's take a look at, see, we did that one. Let's take a look at this very last one. So I want you to pause the video and I want you to think about and try this very last one and how it might be easiest for you to solve it, and then solve it. Okay, so now that you've looked at it, if you're thinking algorithm for this one, you're in luck, because if I take my 10s, 1s, and 100s and I line them up with my 1s, 10s, and 100s, I can actually subtract each of these numbers without doing any borrowing from another group. So 8 minus 7 is 1, 50 minus 30 is 20, and 600 minus 400 is 200. And that gives me my total. So that really is done in 3 steps. But if you did it this way, 437, and then you started jumping on a number line to get to 658, you've got a lot of steps in there and possible chances for an error. If you tried to do constant difference, this number is pretty far away from the next 100. This number is pretty far away from the last 100. I mean, we could subtract if we wanted to. We could subtract 37 and then subtract 37 from that, which could possibly get us into an error as well. So there are a couple of different things, and not always does think before you subtract work, but at least it gets us to a point where we can think, what's the easiest thing I can do? If regrouping isn't your thing, this one right here is the way to go. And this requires a lot of steps. So today what we're going to do is I'm going to have you go to the next slide for our lesson today, and I want you to think about what strategy works best for you. You don't have to use the same strategy all the time, but look and see what might work for you. And if you don't have to regroup like this one, it's the best way for you. Or maybe that number line always works for you. Today we're going to do some practice, and we're going to do practice called More Subtraction Strategies, and it's student workbook page 101. And on that page, I'm going to have you try some of these and practice some of these strategies for which ones work best for you. Have a great day and good luck on that post-assessment. Us teachers are so super excited to see how much your brains have grown this unit. Awesome work. Take those math hoodies off, take a deep breath, and you can finish up your practice. Have a great